Hey, Nichols Chemistry. Welcome to the Nichols Chemistry Roadshow. I'm Professor Chad Young, and we're talking about the difference between incandescent bulbs and LED bulbs. Now, we saw how LED bulbs operate, but incandescent bulbs are a lot different from LED bulbs. Incandescent bulbs give off light like a black body. And you can think of black body as just like it sounds, as a body that is perfectly black. And a perfectly black body will not reflect any light. Now, I've taken a box and covered it in black construction paper. Not a perfectly black body, because when light shines onto it, it reflects to you and you can see it. But if it were a perfectly black body, then any light that shines onto the object would not be reflected towards you, it would be absorbed. I've also cut a hole in this box, and if I put my eye up to the box, I see pretty darn near a perfectly black body. That is, that any light that goes into this hole does not come out. And if I put my eye up to this hole, it's almost perfectly black. It is a black body. Stars, emit light like a black body. They emit light, however, across all different wavelengths. And so let me show you the spectrum of a black body.
These graphs represent the spectra of black bodies of different temperatures. On the y-axis, we have the spectral radiance, or the brightness of the object. And then on the x-axis, you have the wavelength, which also represents the color. So this is the visible spectrum around this wavelength. And then as our wavelength gets longer, all of this to the right of the visible spectrum, that is the infrared portion of the electromagnetic spectrum. I want you to notice here that the 5,000 Kelvin black body, by the way, our sun has a surface temperature of about 5,800 Kelvin. And so this curve represents the spectrum of the light, that is the brightness versus the wavelength of the light output by the sun. I want you to notice that the peak of this curve lies at the color yellow. That's why the sun appears yellow to us. However, there's also a lot of energy in the infrared that is put out by the sun in this portion of the black body spectrum. Now, the tungsten element of an incandescent light bulb has a temperature of about 2,800 Kelvin, or 3,000 Kelvin. So this red curve best represents the incandescent light bulb. Notice here that the visible portion of the spectrum is not at the peak of this black body curve. Instead, it peaks in the infrared. In fact, most of the energy that is put out by this 3,000 Kelvin black body object is in the infrared. And very little is actually in the visible portion of the spectrum.
So, the incandescent bulb, which emits light as a black body, has only a small portion of that light which is emitted in the visible spectrum. However, most of the radiation, or light, that's put out by the incandescent bulb is in the infrared, that it puts out all this energy as infrared light or heat. In fact, only about 10% of the energy that goes in comes out as visible light, and most of the rest, 90%, comes out as infrared light or heat.